Hello student, welcome to the video lecture schedule of operations research. Today we will solve another problem of transportation problem and we will find the optimal solution and minimum cost of the transportation problem. So the question is, find the minimum cost of the transportation problem. Here 3 origin ABC are given and 4 destination are given and the corresponding AI available unit and BJ requirement unit of each destination are given here. So at first we will check whether this transportation problem is a balanced transportation problem or not. So we are finding the value of summation of AI. What is the value of summation of AI? That is 160 plus 150, that means 310 plus 190, that is 400, and 100, that is 500. And summation of BJ, this is equal to 80 plus 90, 170. 170 plus 110, that is 180, 280 plus 160, that is 340 and 440. So summation of AI is equal to 500 and summation of BJ is equal to 440. So these two values are not same. Therefore the given transportation problem is not a balanced transportation problem. So at first we have to make it a balanced transportation problem. For this one we have to increase the value of BJ. So what is the difference between summation of AI minus summation of BJ? The difference between summation of AI and minus summation of BJ is equal to 500 minus 440. This is equal to 60. So we have to increase BJ by 60 unit. That means we have to introduce an imaginary destination with cost 0 at each cell and corresponding BJ will be equal to 60. Corresponding BJ will be equal to 60. Therefore, the balanced transportation problem becomes this. So here we are introducing the imaginary destination H with cost 0 at each cell and BJ equal to 60 because we have BJ is less comparing to summation of AI. That's why we have to increase BJ. Okay, so this is a balanced transportation problem. Summation of AI is equal to 500 and summation of BJ is equal to 500. So this is a balanced transportation problem. So at first we will solve this transportation problem by Vogel's approximation method. Why Vogel's approximation method? Already we have discussed this one because we have to find the optimal solution and we have to find the minimum cost. And Vogel's approximation method is an approximation method which approximate the optimal solution. So that's why always if we have to find the minimum cost or if we have to find the optimal solution, then always we will solve the transportation problem by Vogel's approximation method. For this one we will find the penalty of each row and penalty of each column. Then we will find the maximum penalty. If the maximum penalty occurs in a row, then we will allot in that row, and if the maximum penalty occurs in the column, then we will allot in that column. Now what is the technique? Which cell we have to allot? The cell which containing the minimum cost, we have to allot that cell. So we are applying the Vogel's approximation method and we are getting this is as a final allotment table. Already we know how to solve it. Already we have solved 4 problems by Vogel's approximation method. By using that method we are finding the final allotment table. Okay. Now we have to find how many allotted cells are there. So how many allotted cells are there? This is allotted cell 1, 2, 3, 4, 5 and 6. So in this table 6 cells are allotted. Now what is the value of m plus n minus 1? What is m? M is the number of row and n is the number of column. So number of row is 3, number of column is 3 plus 2, 5. So m plus n, that is 3 plus 5, that is 8 minus 1, that is 8 minus 1 equal to 7. So m plus n minus 1 equal to 7 and number of allotted cell is 6. So since the number of allotted cell is less than m plus n minus 1, therefore we have to allot an insignificant quantity epsilon to an arbitrary empty cell such that no loop is formed with the other allotted cell. No loop is formed means that cell does not forming any square or any rectangle with the other 3 allotted cell. So many unallotted cell are there. Here this cell AD is unallotted, AE is unallotted, AF is unallotted, H is also unallotted. In this way, so many cells are there. Here also BE unallotted cell, BG also unallotted cell, CD unallotted cell, CG unallotted cell, CH unallotted cell. Now among all these unallotted cell, which cell does not forming any loop with the other 3 allotted cell, we will allot epsilon in that cell. Suppose if we consider BE, then we cannot allot in this cell because this cell forming a square with these 3 allotted cell. So these are the 3 allotted cell. So this cell BE forming a loop with these 3 allotted cell. That's why we cannot allot in the cell BE. But is it possible to allot epsilon in the cell AD? Yes, because it is not forming any loop. Just check it. This cell is allotted, this cell is allotted. To form the loop, this cell should be allotted, but this is not allotted cell. So that means this cell is not forming any loop. Now here, this cell is allotted, this cell is allotted, but this cell should be allotted to form the loop, but it is not. So that's why the cell AD is not forming any loop with the other 3 allotted cell. Okay, so that's why we can allot epsilon in this cell. In the same way, we can allot epsilon in the other cell also, but we have to allot epsilon in only one cell. So suppose we are allotting epsilon in the cell AD, okay, so that means we are allotting epsilon in this cell. Now what we have to find? Now we have to find the value of Ui and Vj. What is the formula to find the value of Ui and Vj? We will find the value of Ui and Vj by using the formula Cij equal to Ui plus Vj. By using the formula Cij equal to Ui plus Vj. And what is Cij? Cij is given, that is the cost. Here in the cell AD cost is 42, in the cell AE cost is 48, in the cell AF cost is 38. Similarly, all the costs are given here. Okay, so we will use the formula Ui plus Vj equal to Cij. So Cij is known. Now who are the unknown? Ui and Vj, both are unknown. So how many equation? One equation. How many unknown are there? 2 unknown. So it is not possible to calculate. That's why we have to consider any Ui equal to 0. Now the question is, which Ui we will consider equal to 0? We will check which row have maximum number of allotted cell. The row which have maximum number of allotted cell, corresponding to that row, we will consider Ui equal to 0. So check it. Now in the first row, how many cells are allotted? 2 cells are allotted. In the second row, how many cells are allotted? 3 cells are allotted. In the third row, how many cells are allotted? 2 cells are allotted. So since the second row containing maximum number of allotted cell, that's why we are considering U2 equal to 0. We are considering U2 equal to 0. Now we will calculate Ui and Vj for the allotted cell. So we will mark the allotted cell. This is allotted cell. In the second row, this is allotted cell. This is allotted cell. So we know Ui. So what is the? We can find the corresponding Vj, because Vj equal to Cij minus Ui. What is Cij? 0. 0 minus 0. So Vj equal to 0 here. Here it is 52. 52 minus 0. This is equal to 52 here. Here it is 40. 40 minus 0. This is equal to 40 here. So what is the value? 40, 52 and 0. These are the value of Vj. Now corresponding to this Vj, we will calculate the corresponding Ui. What is the value of Ui? So 40. Now this is allotted cell. Just mark the allotted cell and check whether Ui and Vj are known to us or not. If any one of these is known, then we can find the other. If no one is known, then we cannot find. If both the value are known, then there is nothing to calculate. Suppose this is allotted cell. What is Ui? 0. What is Vj? 52. There is nothing to calculate. This is allotted cell. What is Ui? We don't know. What is Vj? 52. So we can find the value of Ui. What is the value of Ui? Ui equal to Cij minus Vj. Okay. This is the allotted cell. What is Ui? We don't know. What is Vj? We don't know. That's why we cannot calculate. This is the allotted cell. What is Ui? We don't know. What is Vj? 40. So we can calculate Ui. So here Cij equal to 42, Vj equal to 40. What is Ui? 42 minus 40. This is equal to 2. So Ui equal to 2. Okay. Now this is allotted cell. We don't know Ui and Vj. So we cannot calculate. Now this is allotted cell. So Cij equal to 40. Vj equal to 52. So 40 minus 52 equal to minus 12. So equal to minus 12. So it is 2. Now again corresponding to this we can find the other value. So this is again allotted cell. Cij equal to 38, Ui equal to minus 12. So Vj equal to Cij minus of minus 12, that is 38 plus 12, that is equal to 50. Okay. Now this is allotted cell. What is Ui? 2. So what is Vj? 37 minus 2, that is equal to 35. So this is 35 and this is 50. So now we are finding all the Vj and all the Ui. Now we will calculate Ui plus Vj and put it in the circle, within a circle in the non-allotted cell. So for the non-allotted cell we will add this value. So this is a non-allotted cell. What is the corresponding Ui? 2. What is corresponding Vj? 50. What is the value? 50 plus 2, 52. Put it within a circle in this cell. 52 here. So 52 here. Okay. Now for this cell, this is also non-allotted. Where the circle are present, that means these cells are non-allotted. So here this is also non-allotted. What is Ui? 2. What is Vj? 52. What is the summation? 52 plus 2, that is 54. So this will be 54. This is allotted cell. We will not calculate Ui plus Vj for this cell. This is non-allotted. So what is the value Ui? 2. What is the value Vj? 0. 2 plus 0, 2. Put it within a circle in this cell. This is also non-allotted cell. What is Ui? 0. What is Vj? 50. 50 plus 0 equal to 50. So put it within a circle. Now here this is also non-allotted cell. What is Ui? 0. What is Vj? 35. 35 plus 0, 35. Put it within a circle in this cell. Okay. This is also non-allotted. What is Ui? Minus 12. What is Vj? 40. 40 plus of minus 12. That is 40 minus 12. That is 38 and 10. That is 28. So put it 28 within a circle in this cell. This is also non-allotted cell. So what is Ui? Ui minus 12. What is Vj? 35. So 35 minus 12. That is equal to 33 and 23. So this is 23. This is also non-allotted cell. Ui equal to minus 12. Vj equal to 0. Adding this 12 we are getting minus 12. Put it within a circle. So in this way we are calculating Ui plus Vj and put it within a circle in the non-allotted cell. Now we will calculate that cell evaluation. Cell evaluation means delta Ij, and we will calculate cell evaluation for the non-allotted cell, and we will mark the allotted cell by dot. So this cell is allotted, mark it by dot. 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 Similarly, all the allotted cell will be mark it by dot. So we are marking by dot. These are the allotted cell. Now we will calculate delta Ij. What is the formula of delta Ij? Delta Ij equal to Cij minus Ui plus Vj. And we will calculate delta Ij for the non-allotted cell. Okay, come to the previous slide. So this is a non-allotted cell. What is Cij? 48. What is Ui plus Vj? 52. So 48 minus 52, this is equal to minus 4. So this is equal to minus 4. Okay. Now this is non-allotted. 38 minus 54. This is equal to, what is the value? So minus 16. So corresponding delta Ij equal to minus 16. Similarly, this is also non-allotted cell. That's why you are calculating delta Ij. This is non-allotted cell. So 0 minus 2, that is equal to minus 2. So we are getting minus 2 here. This is non-allotted. This is BE non-allotted. 49 minus 50 minus 1. 51 minus 35, that is 16. So these are the non-allotted cell. Now this is minus 1 and this is 16. Now come to the third row. What are the values? This is 39 minus 28, that is 11. 11. This is 42 minus 23, that is so 8. 9. So that is 19. So 19. And this is also non-allotted cell. That is 0 minus of minus 12, that is 12. Okay. So 12. So we are calculating all delta Ij. Now we have to check whether all delta Ij are greater than 0, greater equal to 0, or less than 0 or not. If already we know, if all the delta Ij are greater than 0, then the solution is optimal and unique. If sum of the delta Ij are equal to 0, that is the delta Ij greater equal to 0, then the solution is optimal but not unique. That means more than one optimal solution may exist. But if sum of the delta Ij are less than 0, then we cannot say anything about this solution. So further investigation is required. So here we are finding that sum of the delta Ij are negative. That's why we have to do the further investigation. Now in this cell, the delta ij is negative, most negative. We have to find the most negative delta ij. So this cell is most negative delta ij, containing most negative delta ij. That means we have to allot in this cell. If it is possible to allot this cell, then the other cell, there exists the possibility that the other cell will be also, delta ij value will be also greater than 0. Now to allot this cell, we have to transfer the allotment from the other allotted cell. For this one, this cell should form the loop with the other 3 allotted cell. So now check which are the other 3 allotted cell. This cell is allotted, this cell is allotted, this cell is allotted. So this cell forming loop with this and this cell, because it is forming, these are the vertices of a rectangle, so it is forming a loop. Okay, so we have to transfer the allotment from this to diagonal cell. So which one, now we have to find which one is minimum among these two allotment, this one and this one. Which one is minimum among these two allotted cell? So here this is epsilon and this is 10. Which one is minimum? Minimum element is epsilon, because we have to transfer the minimum allotment. So we have to transfer epsilon from here to here. Since when we are transferring epsilon from this cell to this cell, that means in this column epsilon unit is increased. Then from the next cell we have to subtract epsilon. So 10 minus epsilon. When we are subtracting epsilon from this cell, then in this row epsilon number of unit is decreased. Then we have to add epsilon with 80. When we are adding epsilon with 80, then epsilon number of unit is increased in this column. Then we have to subtract epsilon from this cell. Then it will be balanced. So all the row and column requirement will be readjusted. So we are transferring epsilon. So we are transferring epsilon here to here, then subtracting epsilon from 10, then adding epsilon with 80, and then subtracting epsilon from here. So epsilon minus epsilon, that means now this cell becomes non-allotted cell and this cell becomes allotted cell, and we are allotting this cell by epsilon number of unit. Okay, now what is the next allotted table? So this is the next allotted table. Now epsilon becomes present here. Now since epsilon is a very very insignificant quantity, so 10 minus epsilon is equivalent to 10. So here we are writing 10, and 80 plus epsilon is equal to 80. So this is 80, and epsilon minus epsilon equal to 0. So this is a non-allotted cell. Now again we are calculating ui and vj. As like as before, the second row have maximum number of allotted cell. This cell is allotted, this cell is allotted, this cell is allotted, 3 allotted cell. First row 2 allotted cell, these 2 cells are allotted, and third row 2 cells are allotted, this and this are allotted cell. Therefore the second row have maximum number of allotted cell. That's why we are considering 2 equal to 0. And similarly as like as before, we are calculating ui and vj by using the formula Cij equal to ui plus vj, and we will calculate ui and vj for the allotted cell. So this is allotted cell, Cij equal to 0. So what is the corresponding vj? 0 minus 0, 0. This is allotted cell. 52 minus 0 equal to 52. This is allotted cell. 40 minus 0 equal to 40. Okay. Now this is allotted cell. 40 minus 52, because we are calculating this vj with respect to this. So 40 minus 52, this is equal to minus 12. Similarly we are calculating all other value of ui and vj. Okay. Now then we are calculating ui plus vj for the non-allotted cell and put it within a circle in the non-allotted cell. So we are calculating ui and vj. So 50 plus or minus 14, this is equal to 46, 36. We are putting here 36. Similarly we are calculating ui plus vj for the all non-allotted cell. So here what is ui? Minus 14. What is vj? 0. Adding these two value and put it within a circle in the non-allotted cell. Similarly we are putting ui plus vj and put it for the non-allotted cell and put it within a circle in the non-allotted cell. Okay. Now we will find cell evaluation delta ij, and we will calculate cell evaluation for the non-allotted cell, and allotted cell will be marked by dot. So we will mark in the next table, we will write the blank table and we will mark the allotted cell. This is allotted cell, mark it by dot. 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 this is allotted cell, mark it by dot, and these two cells are allotted, mark it by dot. Now we are calculating delta ij. So what are the delta ij? Now this is 42 minus 26, that is 16. 16. Similarly we are calculating other value, 12, 14, minus 1, 0, 11, 3 and 12. Okay. Here this is minus 1. 49 minus 50, that is minus 1. So it is minus 1. Similarly we are calculating all the value of delta ij. So again we are finding 1 delta ij less than 0. That's why again we have to allot this cell. Now we have to check which allotted cell forming loop with this non-allotted cell. This is a non-allotted cell, that's why we are calculating delta ij. Now we are observing that this is allotted cell, this is allotted cell, and this cell is also allotted. So they are forming loop with this non-allotted cell. So among these two cells, which one is minimum we have to find. Okay, so come to the previous table. Among these two allotted cells, one is 10, here 10 unit is supplied and here 90 unit is supplied. So among 10 and 90, which one is minimum? 10. So we have to supply the 10 unit here. So we are supplying 10 unit here, then 90 minus 10, then 100 plus 10, then 10 minus 10. Because when we are supplying 10 unit from this cell to this cell, then in this column 10 unit is increased. But here what is Bj? That is 90. Already 90 is here. Again if we supply 10 units here, then in this column the unit will be 10 plus 90 equal to 100. But how many units are required? 90. So we cannot supply in this column more than 90 unit. That's why we have to subtract 10 unit from 90. So 90 minus 10, then it will be balanced. When we are subtracting 10 unit from 90, then in this row 10 unit will be decreased. So 90 minus 10 equal to 80. So 100 plus 80 equal to 180. But how many available unit? 190. So in this, from this row 10 unit is decreased. So we have to add 10 with 100. When we are adding 10 with 100, then in this column again 10 unit is increased, because 100 plus 10 equal to 110 plus 10 equal to 120. But Bj equal to 110. So that's why we have to subtract 10 from here. So 10 minus 10. So what is the transferring allocation? So 10, then 90 minus 10, 100 plus 10 and 10 minus 10. Now what is the next allotted cell? So these are the next allotted cell. Again we are considering, again we are finding Ui and Vj, and since the third row have maximum number of allotted cells, again the second row have maximum number of allotted cells, again we are considering U2 equal to 0, and as like as before we are calculating Ui and Vj for the allotted cell. What is the formula? Cij minus Ui plus Vj. That means if Ui is known, then Vj equal to Cij minus Vj, and if Vj is known, then Ui equal to Cij minus Vj. So by using that formula, we are calculating all Ui and Vj, and we are we are finding Ui plus Vj for the non-allotted cell, and put it within a circle in the non-allotted cell. Put it within a circle. Okay. Now this will be minus 13. This should be minus 13. Okay. So minus 13 plus 0 equal to minus 13. Put it within a circle. Okay. This is minus 12. This should be minus 11, because if it is minus 13, then after calculation this will be minus 11. Okay. So minus 11 plus 0 equal to minus 11. Similarly other 51 minus 12 minus 11. This will be 40. Okay. So we are putting all the value of Ui plus Vj within a circle in the non-allotted cell. Then again we are finding delta ij. What is delta ij? Delta ij is equal to Cij minus Ui plus Vj, and we will calculate delta ij for the non-allotted cell. And all the other allotted cell, these are the allotted cell, will be marked by dot. So we mark the allotted cell by dot, and we are finding all delta ij. So here we observe that all delta ij are greater than 0. All delta ij are greater than 0. Therefore, we can say that now the solution is optimal and unique. Now the solution is optimal and unique. So in this table, what are the solutions that are optimal? So x1 3 epsilon, x1 4 160, x2 1 80, x2 2 10, x2 5, 60, x3 2, 80, x3 3, 110. These are the optimal solution. Okay, these are the optimal solution. Here I have written the final allotted table. And what is the corresponding cost? That means the minimum cost. Corresponding to the optimal solution, the cost is called the minimum cost. Okay, just multiply 80 into 40, 10 into 49, 60 into 0, 160 into 37, 80 into 38, 110 into 40. But we are not considering this because epsilon is a very insignificant quantity. So if we multiply epsilon with 38, this will be more insignificant quantity. That's why you are neglecting this value. So after calculating this value, we are getting the value is cost is 1750. So this is the minimum cost. So here what we learned in this lecture, we learned how to do the optimality test. When delta ij are negative, how to transfer the allotment from one cell to another cell. Okay, so until when we have to run this process, until when all delta ij are greater than 0, are greater than equal to 0. Okay, some delta ij may be 0, so but no delta ij cannot be negative. So that's why always we have to make delta ij greater than 0. So we are finding the minimum cost and we are finding the optimal solution of this transportation problem. Thank you.